Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video, we are going to learn how to calculate LCM of algebraic terms. It means in addition to having numbers as coefficients, we are going to have variables with different powers. In fact, by the end of this video, you will be able to solve these examples. Before watching this video, I strongly suggest you to watch videos titled how to calculate LCM of two numbers and how to write prime factorization of numbers first. And I'm going to put the link in the description because I'm not going to explain the strategy completely. What was the formula of LCM? As you probably can remember, in the part which we calculate LCM of two numbers, the formula of LCM is equal to common prime factors with the maximum power multiplied to uncommon prime factors with main power. I know at the beginning it can be a little bit challenging, but you are going to learn that through examples. Let's solve the first example with each other. As you can see, we have two terms. The first one is 30 x to the power of 2 y z. Second one is 12x y to the power of 3. As I told you first, we must write number part or the coefficient as prime factors. So we are going to start 30 with 30. If you don't know how to convert a number to its prime factors, I strongly suggest you to watch that video first. I'm going to put the link in the description. Do you know any prime number that I can divide 30 to that? Yes, I know, and it is 2. 30 divided by 2 will be 15. Do you know any prime number that I can divide 15 to that? Yes, 3. 15 divided by 3 will be 5. Do you know any prime number that I can divide 5 to that? Yes, of course, it is 5. And if I divide 5 to 5, it's going to be 1. When I reach 1, I must stop. Let's go for 12. Do you know any prime number that I can divide 12 to that? Of course, it is 2. If I divide 12 to 2, it's going to be 6. Do you know any prime number? Yes, it's going to be 2 again. If I divide 6 by 2, the answer will be 3. And I can divide 3 by 3, and the answer will be 1. When I reach 1, I must stop. So, as you just saw here, I can write the first term as 2 times 3 times 5. This is the number part, which is 30, and I should not change the variable part. The variable part is x2, y, z. Let's go for the second term. I can write the second term as you can see here. 2 to the power of 2 times 3, and I should not change the variable part, so I'm going to write x, y to the power of 3. Now I want to calculate LCM. As you can see, I'm going to start with the first element. 2 is common between both of them, but here the power of 2 is 1 and here the power of 2 is 2. So it's going to come with the highest power, which is 2 to the power of 2. And again, 3 is common between both of them. So it's going to come with the highest power. What is the highest power of 3? As you can see, the highest power of 3 is 1, and it is same in both of them. I have 5 here, but as you can see, there is no 5 here. So I must write it with its power. Its power is 1. As you can see, x is common here and here between first term and second term. So as I told you, when it is common, it must come with the highest power. The highest power here, the power of x is 1, and here the power of x is 2. So it's going to join with 2. Y is common between both of them, and it's going to join with the highest power. The highest power of y between these two terms, it's going to be 3. And at the end, we have z. We have z in one of the terms, but in the second term, we do not have any z. So it's going to join with its power. Look, this is the LCM of these two terms. And I can write this part, I can multiply these numbers to each other. So 2 to the power of 2 will be 4. 4 times 3 will be 12. And 12 times 5 will be 60. So the answer will be 60. X to the power of 2. Y to the power of 3. Z. And this is the answer of this question. Let's solve next example with each other. Here we have three terms. And as I told you, all must write them with their prime factors. So let's start with the number part. I'm going to start with 20. Do you know any prime number that I can divide 20 to that? Yes, of course, it is 2. And if I divide 20 by 2, the answer will be 10. Again, I'm going to continue with 2. The answer will be 5. And I can write 5 here. I will have 1. So I must stop the process here. Let's go for the 8. Do you know any? Yes, 2, 4. Again, I can write 2. 2 again. I can write 2 again. It's going to be 1. I must stop here. 25. I can start with 5. The answer will be 5. Again, 5. 1. So I must stop. So if I call it first term, and if I call it second term, and this one third term, I can write them as, let's start with the first term. As you can see, in the 20, there are 2 2's and 1 5. So I can write it as 2 to the power of 2 times 5. And I should not change the variable part, a to the power of 2, b. Let's go for the second one, second term. As you can see, I can write 8 as 2 to the power of 3. 2 to the power of 3 times, I should not change variable part, so I'm going to have b, c. And third part, as you can see, 25 is 5 to the power of 2. 5 to the power of 2, I should not change the variable part, a 2, c to the power of 2. Now we want to calculate LCM. Let's start with the number part. So look at the first two terms. Here I have 2 to the power of 2, but here I have 2 to the power of 3. I know that 2 is not common between all of the terms, but if it is common between two terms, it would be enough. It's going to come with the highest power. So we are going to have 2, but what is the power of 2? Here the power of 2 is 2, and here the power of 2 is 3. So it must come with the highest power. After that, we have 5 to the power of 2 in the third term, and we have 5 in the first term. So it's going to come with the highest power. What is the highest power of 5? Of course, it is 2. After that, we have a in the third term and in the first term. It's going to come with the highest power. The power of both of them is 2. So it's going to join with a to the power of 2. Of course, we have b here and b here. So it's going to join with the highest power. The highest power will be b. And here we have c. And here in the second term, we have c as well. It's going to join with the highest power. What is the highest power of c? As you can see, it is 2. I can convert this part to a number. So LCM will be 2 to the power of 3 will be 8. 8 times 5 to the power of 2 is 25. So 8 times 25 will be 200. And we are not going to change this part. A to the power of 2, B, C to the power of 2. And this is the answer of this example. Okay, here we have the third example. But before solving example, let me tell you something. Sometimes in this part, the students ask me, is it possible to calculate LCM of the number part with writing multiples? Yes, it is possible, but I do not suggest you. I suggest you to use prime factorization method because writing multiples is time consuming and the possibility of making mistake is really high. So I'm going to start. This is going to be the first term. And here we have the second term. And here we have the third term. Let's start with the first. Coefficient 15. Do you know any prime number that I can divide 15 to that? Of course, 3. The answer will be 5. I can divide 5 by 5. And I will have 1. Do you know any prime number that I can divide 18 to that? Yes, 2. After that, 9, 3, 3, 3, 1. 9, of course, I can divide it by 3. This is going to be 3. I can divide it by 3 again. This is going to be 1. So for the first term, I'm going to have, as you can see, 3 times 5. And I should not change the variable part, x times z. For the second one, I have 2 3's and 1 2. So I'm going to have 2 times 3 to the power of 2, y, z to the power of 2. For third one, I'm going to have 3 to the power of 2. So 3 to the power of 2, x to the power of 2, y, 2. Y to the power of 2. Now I want to calculate LCM. Look, here I have 3 in the third one. In the second one, I have 3. And in the first one, I have 3. So it's really simple. I'm going to write 3 because it's common between all of them. What is the highest power of 3? As you can see, it is 2. Here is 2. Here is 2 again. Here is 1. The highest power is 2. Here I have 2. And it is not common between 2 and any other of them. So it's going to come with its own power. And here I have 5 and it is uncommon. It's going to join with its own power. Here I have x. In the second one, I do not have x. In the last one, I have x to the power of 2. So it's going to join with the highest power, which is x to the power of 2. Here I have y. And here I have y to the power of 2. So it's going to join with the highest power, which is 2. And here I have z. And here I have z to the power of 2. So it's going to join with the highest power, which is z to the power of 2. So I can write LCM as 3 to the power of 2 will be 9. 9 times 5 will be 45. 45 times 2 will be 90. 90. X to the power of 2. Y to the power of 2. Z to the power of 2. And this is the only correct answer of this example. Here you can find more examples and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write them in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.